I think it's recording. Okay. Hello, everyone. Everyone had a good Christmas, Boxing Day. Everyone's enjoying their break in general. And yeah, this is. Okay, let's start again. All right. Hello, everyone. Hope you guys are enjoying your break. Hope you had a good Christmas, Boxing Day. And I wish you all a happy New Year. Yeah, this is the session 5 of the blockchain analytics series. And yeah, so what we've done so far is we've just had like a first session was just an introduction, teaching you the basics of SQL. Second session was about like decoding raw data on Ethereum and how the Ethereum virtual machine works. And then the third session was on decentralized exchange data. The fourth one was on NFTs, and this one will be on NFTs as well. So yeah, let's just get into it. I should probably share my screen. How do I do this? Uh, yeah, cool. Yes, session 5. Today I'll just cover briefly again what NFTs are, NFT token standards, and then an example of decoding a NFT specific event. And then we'll also look into the NFT trade spell on June. Yeah, this session is going to be quite short, given that we've already covered NFTs, and I just wanted to, I guess, use NFTs as an example to show what you can do. Yeah, I'll leave it at that. We'll go into it. And yeah, the slides are on Discord. But yeah, we mentioned, or Jameson rather mentioned last session that NFTs stand for non-fungible tokens, which basically means like each NFT is not interchangeable for another. So it's like one of a kind, has unique properties, and it's kind of different to ERC20 tokens, which are just normal cryptocurrencies on Ethereum. But you can exchange one Ethereum for another Ethereum, and no one will bat an eye, basically. It doesn't make a difference. It's like £1. £1 is the same as another £1. You can't say the same thing for NFTs. And you can usually see stuff like this in the real world with art, which is why a lot of NFTs are in the form of collectibles or like, profile pictures of digital art, you could say. And then they also come in other forms like music, videos, legal documents, anything really that is sort of unique or one of a kind. And so on Ethereum, you have different token standards. And the reason you have token standards is because it makes life much easier in building composable systems, basically. Things that can talk with each other, exchange with each other. Like you'd want things to generally share the same properties. Otherwise, it becomes very difficult in transferring things or moving things from one place to another because you need to account for different features in your code, which can become a headache. And so ERC20 tokens are just fungible tokens, and they have a list of compulsory functions. So transfer, balance of total supply, from approved allowance, and then you also have the optional parameters such as the token name, the decimal, the symbol. Most if not almost, yeah, if not all big or used ERC20 tokens have the token name, decimal, symbol anyways. And then you have like ERC721, which also share, and those are non-fungible tokens for NFTs. And they share some features from the ERC20. Then they also have ownership functions, and they're represented by a parameter known as a token ID. And the token ID is basically the thing that makes it unique. And then you also have other token standards. That should be ERC1155, not ERC115. But yeah, that's another standard that lets you batch multiple tokens together. And then you also have soulbound tokens, which I haven't put in the slide, which are non-transferable tokens. And these are normally like certificates and badges, proof of participation stuff. Yeah. And yeah, like NFTs have been around since 2016, although a lot of people would say that they colored coins on the Bitcoin network in 2013 was some form of an NFT. And yeah, Pepe the Frog was the first NFT issued on Counterparty, which is on Bitcoin. And then in 2017, you had CryptoPunks and OpenSea launched their marketplace. And then before 2017, you also had like CryptoKitties on Ethereum as well. Um, and in 2018, you had the launch of Axie Infinity, which was like the first pay to earn game. For those who know about that, you probably have like heard about the rise and fall of it and the whole Ponzinomics behind it. But yeah, in 2020, you had the NBA Top Shot, where you could buy like basically like a video or a GIF of like a basketball player dunking or doing something, and you'd own the rights to it. And then you had Decentraland, which is sort of like the start of the metaverse narrative. And then you had Rarible, which is an NFT marketplace launch. And 2021, you just saw the rise of NFTs. You had the whole boom and hype cycle. And as a result of that, a lot of protocols tried to penetrate to the marketplace uh, area. And so you had protocols such as LuxRare, which we'll go into in this session. And then you also had Solana becoming a competitor to Ethereum for the blockchain that was very popular with like NFTs. And then you also had like almost every major company launching some form of NFT initiative. Like during the cycle, we had like Pepsi, and recently, well, this is after the bull cycle. You've had like Starbucks and Reddit having some success with it as well. Um, And then, these slides were made like a few months ago, but like a few months ago, Suda sort of launched a very novel architecture for NFT marketplaces. Um, and it was like instead of like the previous model where you had someone list an NFT and you'd have someone bid, and then you'd have like a sort of like I don't know, like an auction system. Like you had someone bid and someone accepted that bid and blah blah blah. Um, And then yeah, so it's just sort of like how it works on eBay really. But then Pseudoswap came up with like a very novel architecture with like trying to replicate what you see in decentralized exchanges, where you had automated market makers. So how it would work is a liquidity provider would deposit NFTs or some like ETH or ERC20 token into the pool, and they choose whether they would like to buy or sell NFTs or both, and they'll specify a starting price. And then you also have like different bonding curve parameters. So you have a constant linear exponential. I'm not going to go too into it. You can read up on it if you want. And then users can then buy NFTs from or sell NFTs into these pools. So every time an item is bought or sold, the price to buy or sell another item changes for the pool based on its bonding curve. At any time liquidity providers can change their parameter of the pool or like withdraw assets. But yeah, read up on Pseudoswap if you want. Quite interesting. And then you have like you can also categorize NFT marketplaces into open and selective. So the open ones allow anyone to launch, mint, and offer NFTs, while the selective ones like curate it themselves. And so most likely you'll see higher quality projects on the selective ones. Yeah. But just to reiterate, this is how like the sort of architecture works on June. So you have raw data, so like the transaction traces and logs, and we've been through this a few times already. And then those are used to create the targeted events and calls. And then you could collate all of these and aggregate all of these into a spell, which is a very much more clean version of specific thing. So NFT trades would be an example of an NFT specific spell. Um, so yeah, actually, like before, let me just show you what NFT trades is. Uh, okay, you can see this. Let's go. Something new. It has this very nice like loading feature for Christmas. Wait a second now. While it's loading, you can look in here and see all the fields that are available in the table. They have a unique trade ID, which is like just a unique identifier of the trade, I guess. The version, I'm guessing, a bit annoying because this isn't in order, I think. Or if you, yeah, I don't think it's in order. But like version is the version of the platform. So sometimes NFT marketplaces will upgrade their protocol to introduce new features. And so yeah, you can see, um, yeah, what's archipelago? Oh, it's okay. It's an NFT marketplace. I actually didn't know of this. But yeah, cool. And then you have like the block time, the token ID, which is a unique identifier we mentioned, and the name of the collection. So art blocks is one of the largest collections. Um, Token standard, the trade type, and just some other cool stuff. Um, but yeah, have a look around when you have the chance. And yeah, back to slides. Right, let me don't know what's going on here. Oh, okay. So yeah, so I mentioned Looks Rare as being like one of the newer NFT marketplaces. Well, not new. It launched in February 2022. Then it introduced a very novel like tokenomic scheme for an NFT marketplace in which it tried to incentivize trading activity. Um, Whether it was intentional or not, it didn't incentivize organic trading activity at least. And the way it worked was users could buy and sell NFTs from selected collections and earn Looks tokens as rewards. And then users who stake Looks as well were rewarded with 100% of the trading fees. And then all the ETH fees that were accumulated from the sales were combined at the end of like every given period, or like I think every day, and distributed to Looks token stakers. So basically, what happened was what you could do is you could just set up multiple wallets, and just trade between those. And what would happen is, so you'd get Looks tokens as rewards for trading those, and then you could also stake the Looks you got to earn even more like Looks, if that makes sense. Um, so yeah, um, we'll go into that a bit more on how to. Yeah, okay, we'll leave that there for now. And I just want to mention on Looks Rare, whenever someone wanted to buy an NFT with the ERC20 token, and they submitted that order bid, I guess. Um, you have a an event that will get emitted called Make a Bid, and then when that offer gets accepted, you get an event called Take a Bid. Um, and then similar for selling, you have Make a Ask and Take a Ask. And the way I know this is just by looking through. You could either look through the Looks Red doc, which explains things very well, or you could go into the specific smart contracts in Looks Rare, which are also in the docs, and read through the code. Um, so yeah, let's have a look at the logs of the exchange contract address, and again, the exchange contract address is in the Looks Rare docs. Um, and yeah, let's look at the take or ask event. There's the take or ask hash event. And the way I got this hash was literally by going into this on Etherscan. I got this from the Luxfer doc. So just copy and paste in the contract address I got from the Luxfer exchange. And I basically just like, you could either go into events here and find like a hash with one of the logs. Like, yeah, you take a Rask, you go in here, go on logs, search, take a ask, and see that's topic 0 basically, or topic 1 on June. Or a much more long-winded way would be to go back to the contact address and then just basically like search in the transactions. Just like search for a take or ask, basically. There could be one here. Oh, it'll take a bit. Never mind. Basically, it's a long way. You just keep going until you find one. But it's much easier to actually go back and look at the events tab, and I'll show you a transaction with an example of that has emitted one of like these logs. All right. While that's running, maybe. Yeah, so this is just another explanation of how the hash is even generated, and it's just using the, I don't know how to pronounce it, it's like 256 hash. And yeah, we've gone through this before, but like, if you go into the logs of the transaction hash that has emitted a take or ask event, what you'll see is the contract address at the top of where the event is emitted from, and then the name of the function with the parameters that are passed into it. So you'll see bytes 32 order hash. Order hash is the parameter, bytes 32 the data type. Then you see uint 256 order nonce. Order nonce is parameter, uint 256 is that, and so on and so forth. And then you also see index underscore topic 1, index underscore topic 2, index underscore topic 3, next to 3 of the parameters. And so that just basically means, and we've mentioned this before, but it just basically means that they've been indexed, and so they've been separated out of the data field, which makes it easier for people to just get data, I guess, instead of having to decode what's in the data. Within the data, everything is stored as like a hex, basically. So you can see the bottom there. And so you'd have to go through some work of decoding this data, like all these zeros and random letters, to get what you see in this line, basically, on the data field. So yeah, you should have topic 0 as the hash of the whole event name and the data types passed in. Topic 1 as the take address, topic 2 as the make address, and topic 3 as the strategy address, which I don't actually know what that is. But and yeah, again, just reiterating things we've learned previously. Like all the index topics apart from topic 0, which is topic 1 of June, are addressed right. So you can see index topic 1 address, index topic 2 address, index 3 topic 3 address. And the reason why topic 0 isn't of address type is because it's the hash of the whole thing. And if you don't know what I mean by the whole thing, maybe go back to like either session 2 or go back to session 2 or session 3. You should clarify it. That means. And just a reminder that everything is padded to 32 bytes on the Ethereum virtual machine, and so like if an address was in the data field, or like if it was stored in the EVM, because an address is actually 20 bytes on Ethereum, you'll have like 12 leading zeros before, so you'd have to take that into account when decoding stuff. And this is what I've done here. So so from Ethereum.logs, we're looking at this contract address, and this topic, which is the hash of the take or ask event. We'll just look at a specific transaction hash just to minimize computational time, I guess. As well as it's just better when decoding stuff that you first look at a specific transaction, get that right, and then apply it to the rest. Just makes it less messy, I guess. But yeah, let's just see. Hasn't finished running yet. It's a bit annoying. Oh, but yeah. So from Ethereum logs, this is the exchange address. Put some random, yeah, some random transaction. You could probably go on Etherscan and search this transaction up. You go on logs. Yeah, you get a take or ask event there. And the goal is to basically decode all of this. Or this is sort of already decoded for you, given it's an index topic. But yeah, decode all of this as well because it has some useful information. And you can also view source here, go into the contract, and like find all the code. And you could probably like search for the take ask. And you can see right at the end of the function, it will emit a take or ask event. Okay, it's not loading, but what basically happens is you get so I take a substring. So this I'm pretty sure we've gone through the substring function before. A substring of topic 2, which is topic 1 in Etherscan, what June ships it for some reason. We did a 3+ because taken maker and strategy because they index topic. They start with like 0x something, and so we want to start on that something and take away the 0x. And then we do 12 times 2 because why do we do 12 times 2? Oh yeah, because it's 12 leading zeros, because addresses are padded to 32 bytes and an address is 20 bytes. So that leaves 20 leading zeros. Okay, yeah, 0x plus like 12 leading zeros. And for 2 characters is 1 byte, but you have to times it by 2. Sorry, not 12 leading zeros, it's 12 bytes because 24 leading zeros. Yeah. And then you have 20 bytes. Yeah, that makes sense. Okay, cool. 20 bytes, which is 40 string characters. Yeah, that makes sense. Okay, cool. Yeah. And so you do that for each and every single one of them. I hope that makes sense. I think it will make more sense if you guys do it yourself. So that just instead of uh this, just have substring topic 2. Oh, literally just do topic 2 as taker. Topic 2 as taker. Topic 3 as maker. Topic 4 as strategy. And then like see what you get. And then after that, do substring this and see what's changed. And you'll basically see like the leading zeros have been taken away, basically. But then you also notice that there's no 0x in front, so you have to do a concat with a 0x. So yeah, let's go back to the slides. Yeah, so now what you find is you have a data field that looks very like long and no one knows what the hell is going on. like 0xDA6662, blah, 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 with all these zeros and random numbers and letters. And so like we mentioned before, our goal is to go and decode from this, we see the data figure at the bottom, to that. And luckily I have made it a bit easier for you, and I've color coded it. And so you start off with a 0x again, like I mentioned before with the other ones. So that's 2 characters. And then you have an order hash, which is 64 characters long, for 32 bytes. And the way you take that is you do 64 plus the 2 because you don't want the 0x. So you're basically telling the function where you want to start from. So you plus 2 plus 64, which is this orange, and then plus 1. So you want to start from this 0. And that's how you take the ordinance. Okay, this is confusing because correctly. Yeah, it hasn't been shifted correctly. I apologize for that. I'll fix this later. But that is wrong. That's meant to be this here. Because this is just meant to be the substring data 2 plus 1, 64, not 64 plus 2 plus 1. Because 64 plus 2 plus 1 is saying to start from here. We want to start from there. So that is actually for this. And that is actually for this. And so, yeah, okay, yeah. Becomes more clearer here. So like the order hash, you start from the 0x plus 1, 64. And then the ordinance is 64 plus 3, 64. And then, yeah, and so on and so forth. I hope that makes sense. That should make sense. Still running. Oh my God. Okay. Just trying to see if what I said was right or just complete bullshit. Yeah, it's right. Okay. Order hash, ordinance. Oh, there you go. It's here. Yeah, so this is from here, like the first query was still there. Okay. Yeah, you can see like the very long-winded data field. And then you have like topic 4, topic 3 with all these leading zeros. Um, yeah, okay. Just trying to see if it's correct. You know what, let me just oh God, I just see that. Okay. 64 plus 3, 64. Yeah, okay. Okay, ignore this. Just have a look at this code here, and that should make it much more clearer. The color code thing is correct. It's just that these numbers are not correct. It's a bit annoying, so I apologize for that. Um, and neither is this code. Great. Yeah, okay, just have a look at the code. Ignore and I'll link the code in the description as well as in the Discord. Um, and that should decode all of the transactions for this event. And yeah, just to reiterate what we've done is we've just basically looked at the logs of the raw data in Ethereum. We've decoded it into a take or ask event, and you can also do a take a bid event likewise, and then you'll use that in the spells through a union or and that's just basically like the whole process of creating and aggregating all this data. All right. Let's actually look at the spells that's been created in on the NFT.trades abstraction. So I showed you before from the beginning, like what the NFT.trades spell um, looks like. Um, so let's run this query, and you can see from NFT.trades where the blockchain is Ethereum and the project is looks rare. Select so truncate all the block time fields by day, sum the USD amount, and group by day. So basically, we're finding the daily volume. And notice the order in what I've said it in, and it should be something that you go into the habit of when you read queries. Don't necessarily read it from top down, because especially when you're trying to optimize queries, it's much better to think about the order of execution, which we went through 2 sessions ago, I believe. Um, so what the code does first is looks at this table and then goes, okay, what do I have to filter for? And then it goes back up here and says, okay, I'll select this stuff. Um, actually, let's group by first, right? Pretty sure let's group by first. To order of execution. Yeah, it does a group by first. So it does from where, then groups it by day. Oops, and then selects this stuff. And so you can find the daily volume here. And a task for you, try and filter for the past 2 years. So, I mean, that shouldn't be too hard, I guess, because it only goes back to less than 2 years ago, anyways. So, um, but the clue is just to add another filter. What else? Oh yeah, and alternatively, instead of um, just grouping by the day, we can also group by the project. I mean, in this query, it makes no difference because we're also filtering for where the project is specifically looks for. I'll take that away after this runs, and you can see like the difference. Yeah, so it makes no difference because we're already filtering for a specific project. But I can take this away. Actually, does it take away here? No, it doesn't. Okay. Oh, nice. So you have alphabetical foundation. Okay, cool. And then June has this very nice feature where you could just easily create a visualization. So I guess we'll do that just to quickly show you how you can make charts and stuff. Um, I recognize that this course doesn't actually focus too much on visualization, which is a very important aspect of like data analysis. Um, so maybe we'll do that in the next session actually. So new visualization, bar chart. You can also do like areas chart, all these different other charts. Um, and what you'll have to do is come in here, change daily volume. Oh, nope, doesn't look. It should be daily volume and then group by project. And so you can see, I don't know why it's faded out like that, but let's try and add some. Oh, it's because the colors. Okay, add some random colors in. Hmm. I don't know why it's. Oh, okay, yeah. It's enabled stacking. Okay. Cool. And then you can also like you can see like there's all these like there's so many decimals. You could change that. Wait, how do you do this? You do the y-axis, take format. You can go on the June docs, it shows you like how to do tick and label formatting. See, that's much better. Yeah, cool. And you can like normalize the percentage if you want. Um, take this off. Yeah, so you can see like historically, like OpenSea has had most of the market share, and then like during this period, um, LooksRare just basically basically like ate up the whole market and then went all the way back down. And this is like around when they turned off their, like wash trading stuff because found out it was basically Ponzinomics. Um, and then OpenSea went back to dominate basically. Um, um, and so yeah, just showing what does done. And so I mentioned, or mentioned multiple times that most of this volume was not organic, and the way you can check is by basically filtering for wallets that have traded back and forth with each other. And so one of the ways that people did wash trading was to just set up multiple wallets and trade it back and forth. And so there's a very neat way of um, finding that out. And so just go back here. So I create a common table expression, so a CTE with this with clause. Put the query inside these brackets here. So from the NFT.trace table, and we'll call it NFTT. Um, and where the blockchain is Ethereum, where the project is looks rare, and inside here we're gonna put in a subquery in our like our workflows. So what we do is we go back into NFT.trades and we call it NFTT2. And it just makes it easier here. So where the seller of the second table is the same as the buyer of the first table. Um, and then NFT contract where the contract address is the same, where the token ID is the same, where the project is Luxembourg, and where the blockchain is Ethereum. Let's count how many of those there are. And if the count is not zero, um, then that would basically mean that this is a wash trade because there's been back and forth selling. And obviously we group by one because there's an aggregation function in what we're looking for. And so we can find all the transactions that were wash trades basically. Um, so yeah, there's just an example of how you can use subqueries and nest it into like a where clause. And so what it does is you have one table, and then every time as it goes through every single row, it will check against a copy of that column and see, okay, where does the buy and seller match and the NFT contract address match and the token ID match and the project and the blockchain. And that would basically mean that this trade was a back and forth with this trade. And so we'll count that as a wash trade. Um, yeah, okay. And so there's a table here that just explains everything. Um, yeah, so that's just this is an illustration of how you can wash trade basically. Um, and then yeah, there's just another visualization of that that query that I wrote. If you were to do a bar chart of the filtered volume, and you can see in January and February the amount of wash trades was very high, and then eventually it just the volume died down. So this is the filtered volume. So this is so what you would do is you do a left join with the NFT.trade. So you do select asterisk from NFT.trades where blockchain equals Ethereum, where project equals looks rare, left join LR underscores filtered underscores volume, which is the table we created, where the transaction of the um of the LR underscores filtered underscores volume dot transaction hash is null. So okay, you do select from NFT dot trades where blockchain equals Ethereum and project equals looks rare. And then you do a left join. Oh, no, actually, you do a left join here. What am I doing? And underscores underscores volume where NFT dot trades dot blockchain. Oh, this NFT to make life easier. Uh, just call it LR. And LR dot transaction hash is null. So what's this saying is we're going to do a left join. So we keep everything from NFT.trades, and then we also filter for Ethereum and blockchain, Ethereum and looks rare. And then we do a left join. So we keep everything on the left on that left table, the filtered NFT.trades table, as in filtered for Ethereum and looks rare. And then we try and join it with this filtered. It's actually not the filtered because this is like the wash traded, right? So select count. Yeah, so this is not the filter. This is like the opposite of the filter. This is like the things that need to be filtered out. And so we do a left join, so we keep everything from NFT to trades. And so what it's saying is if the transactions that need to be filtered out are not in the left join, so it'll show up as a null, then those are legitimate trades. And so you can, yeah, hope that explains it properly. Um, and yeah, that's basically it for the session. I just wanted to show you an example of how someone took initiative and landed a job, basically. So this guy's Noah. He goes to Stanford. He's undergrad, and he just created like a very nice dashboard on NFTs. Yeah. So but he created this very nice dashboard on like Adidas NFTs, Nike NFTs, and he got featured on like multiple like publications like Time Magazine and Vogue Business, and then he just ended up getting a job at Nike. So just like some motivation for you guys to put in the work. Um, and yeah, that's it. An extension of your own, create an NFT dashboard with metrics of your choice. Maybe you could get a job. Um, and next session, we'll talk about bridges, the June's parameter feature, moving averages with window functions. Yeah, we've covered window functions, but like I think it would be a good idea to talk about moving averages because that's like a very prominent like metric used in data analysis. Um, and yeah, I think that will probably be our last like session where we do SQL. We might do another session where we get like data analysts to come in and talk about like their career experiences in Web3. But yeah, this is basically our second last like coding uh, session of the series. Um, yeah, thank you for listening, and I hope you guys enjoy the rest of your holidays. Okay, how do I stop this?